All right, welcome back to Mr. P Helps with Precal. This is Unit 4, Topic 3, Lesson 1. We're going to start with this. I'm actually going to split this video in half, and we're going to start with just graphing polar coordinates. We're going to start off with a warm-up, which is on what we had done in the last video, which we talked about parametric equations and eliminating one of the parameters and changing it into rectangular form. So we'll always take the x equals parameter, which is the horizontal distance, and set it equal to t. So I'm going to add 1 to both sides. That gives me x plus 1 equals 4t, and then divide both sides by 4, so that t equals x plus 1 over 4. Then I'm going to take this equation, if that's what t equals, I'm going to plug it in for t right there, so that y equals 6 minus x plus 1 over 4. Now, the next thing I'm going to do is I won't want it to be divided, so I'm going to get rid of that by multiplying everything by 4. So 4y equals 24 minus, and then times 4 here just cancels. So you can basically see what I'm doing. So this times 4 is 4y, this times 4 is 24, and this times 4 basically just cancels out, leaves you with just x plus 1 in parentheses. Now keep in mind that that has to be distributed. This negative sign is distributed to both. So that 4y, this 24 minus 1 makes 23, and then negative x. And I'm reversing the order of it because I just prefer to be x and the b, but it really doesn't matter in the end. All right, I'm going to do the same thing over here. I'm going to take the x coordinates. I'm going to subtract 5 from both sides. X minus 5 equals t squared. Square root of both sides so that t equals both positive and negative square root of x minus 5. All right, so I'm going to take this, I'm going to plug it in for t right there so that y equals 3 times positive or negative square root of x minus 5. And it looks like that's all I can do. And there's your answer in rectangular form. All right, so graphing polar coordinate systems. So you've done Cartesian graphs, which are graphs that are, squares with 4 quadrants. Well, these are circular graphs. So that's what a polar coordinate system is. So it's kind of like the poles, if you think about it, of the Earth. The North Pole and the South Pole. It kind of looks like that if you think about it. To form the polar coordinate system, you fix a point O. So O is a fixed point called the pole. So the pole happens to be the center of the coordinate system. And from O, construct an initial ray called the polar axis. And it shows you right there. So that's the initial ray that's always going towards 0. And then the R is the direction, the R is the radius of the circle that's created. It's directed distance. So I know we've done like vectors quite a bit. So basically R is like the magnitude of the vector. It's the magnitude of this vector which leads to here, which is the reason why we did vectors first. And then theta represents the angle in which it is, which is what you did for vectors as well. So very similar to what we have been doing. So it says concentric circles are frequently shown on a polar coordinate system. Concentric circles just means circle inside of a circle, all with the same center. So graphing these points, and then like I said, I'll make another video on the other half of this, which is conversions. So point A happens to be at 2, 7 pi over 6. Now, you got to remember that unit circle, and I know some of you dreaded having to memorize that whole unit circle thing, but 7 pi over 6, so remember anything over 6 is a 30-degree, multiple of 30 degrees, and 7 times 30 is 210 degrees. So this is basically a 210 degree. Now, don't really need to know that because you do know that it's going to be right here along this line, and it's going to have an angle of 2. It's going to have a radius of 2. So find 2. 2 is going to end right there's my answer. So that would be point A. So point A happens to be, it's 2 away from the center, and it's at 7 pi over 6. Point B is going to be half. So that's going to be on this circle right here. But it's also going to be 3 pi over 4. So remember, 3/4 pi is almost 4/4 pi. So that's 1/4 pi, 2/4 pi, 3/4 pi, and then 1/2 will be right there. Getting specific, that's point B. So C is at 3, negative pi over 3. So negative pi over 3 means we're going backwards. Pi over 3, remember, is 60 degrees. So instead of going this way 60 degrees, we're going to go this way 60 degrees. 5 pi over 6 is 1 pi less than 2 pi. I'm sorry, it is 1/3 less than 2 pi because 2 pi would be 6 pi over 3. So 1 less that would be 5 pi over 3. So I know it's in this direction, but then I also know it's got a radius of 3. So that's, I got to be careful when doing this. This is 3 all the way on the outside, so it's right there. So that's point C. Now, D gets a little bit trickier here in the fact that it's -1. So I'm going to do the angle first always. So pi over 4 is 45 degrees. That's right here. This is pi over 4. I know it wasn't listed. That's 2 pi over 4. This is 3 pi over 4, 4/4, 5/4. I'm just adding these because they weren't there. 6/4, and this is 7/4 pi. All right, so now that I have that, but it's -1. So it's actually not going this direction with a magnitude of 1. It's going, remember, in vectors, things with a negative, so things that are opposing vectors are ones that have a negative instead of as opposed to a plus. So therefore, it's going the opposite direction 1. So instead of going this way to pi over 4, it's going this way -1. So it's right there. So instead of going towards pi over 4, it's actually going towards 5 pi over 4, which is the exact opposite direction. And that would be letter D. -2.5, 4 pi over 3. Okay, so positive 4 pi over 3 is right here. So that's in this direction, but it's negative, so it's not going to go towards 4 pi over 3. It's going to go over towards pi over 3. 2.5. Okay, 2.5 looks to be right there because there's 2, there's 3, and that's the line in between for 2.5, and that would be letter E. And then one last one, and then I'm going to call it quits here. F is -3, negative pi over 6. Okay, double negatives here. So first of all, we're not going to go this way pi over 6. We're going to go backwards pi 6. So instead of going this way 2 lines, we're going this way 2 lines. So it's along this line right here, but then it's -3. So this would be +3 negative pi over 6, but instead it's going in the exact opposite, which would be right there. And that would be point F. All right, like I said, I'm going to stop right there. Thanks again for watching, and look forward to future videos. Please give it a like if I helped you learn about how to plot points on a polar system. And we'll start doing conversions rectangular to polar and vice versa on the next video. Have a great day.